Welcome everybody to this webinar on collective intelligence in the era of LLMs. From our experience, it takes a couple of minutes for people to join, so I'll just dabble a bit the first couple of minutes before we start with the talks. I'm very excited to have our speakers for this webinar series, Jason Burton, Lucy Fleck, and Nicolas Seller. On the slides, you can see their affiliations and the talk that they're going to give. This webinar is part of a series from the HACIT EU Horizon Grant project, and our overall topic is hybrid human artificial collective intelligence in open-ended domains. And I invite you to visit our website to learn more about it. Two of the case studies we're looking at are medical diagnostics and climate change adaptation management. Medical diagnostics is one of the topics featured today. And actually, there will be another webinar next week from our partners at the Met Office on using hybrid artificial collective intelligence in the context of climate adaptation, climate services, and smart agents for decision support. You can also find information about this webinar on the website. So I think people are still entering, so just return to our starting slide and we'll start in a couple of minutes. Now 5 past, I think we can go ahead and I'll give the floor to Jason with his talk on how large language models can reshape collective intelligence.
All right, so hopefully everybody can hear me. Nice to see everybody. Lots of familiar faces and names in the room, which is great to see. I'm Jason Burton. In this talk, I'm going to share a few insights from a recent collaboration of 28 researchers, where we tried to provide a comprehensive overview of what the advent of large language models means for the collective intelligence of organizations, communities, and society at large. So when I talk about collective intelligence, I'm referring to the phenomenon where individuals act collectively to produce some shared outcome or display some capability that oftentimes could not have been produced by any individual acting alone. So when the estimations of many individuals are aggregated together into a collective forecast that's more accurate than the average individual's estimate, that's collective intelligence. And when an organization facilitates collaboration among diverse individuals to create goods and services that no single person could create, that too is collective intelligence. But of course, collective intelligence is not something that's guaranteed. Not all collectives display collective intelligence. Collective intelligence is something that needs to be stewarded, something that will only emerge when certain elements align. One of these elements is diversity. And when I say diversity, I mean functional, deep-level diversity, which refers to differences in how people represent and solve problems. Functional diversity is useful because when individuals in a group approach a problem in different ways, it helps ensure the group thoroughly searches the space of possible solutions. It'll also help ensure that if and when individuals make errors, they should, at least in principle, make different errors that cancel out in aggregate. A second key element is individual competence. So intuitively, it's true that the individuals in a collectively intelligent group should have at least some competence relevant to the task at hand, but individuals don't necessarily need to be experts. The need for individual competence depends on the task and the degree of diversity present. So for increasingly homogeneous groups with little diversity, the individuals must be increasingly competent. That's because with little diversity, a group likely won't search a solution space thoroughly, but that might be okay if the individuals are very competent and already know exactly where to search. In contrast, a group with lots of diversity can afford to be less individually competent because even though the individuals might make lots of errors, those errors should cancel out in the aggregate. And the third key element here is aggregation. So as I've alluded to already, an appropriate aggregation mechanism is needed to translate individual beliefs and behaviors into a collective outcome. That mechanism can be something formal and explicit, like, for example, having all individuals submit votes or estimates to be averaged, or that mechanism could be something more implicit. So, for example, the self-interested buying and selling behaviors of stock traders could be implicitly aggregated and reflected in the market valuation of an asset. So which kind of mechanism is appropriate will depend on the task environment. And so the main message I want to convey here is that to understand how collective intelligence will fare in the era of large language models, we can think about how large language models will affect these three elements and the interplay and alignment between them. So for instance, to find ways in which large language models can promote collective intelligence, we might look for applications that could facilitate more diverse collaborations while also augmenting individuals in ways that increase average individual competence. Let's consider just one potential application, which is using language models to mediate deliberative processes. So lots of situations where people aim to elicit collective intelligence involve deliberation. You can think of hiring committees, citizen assemblies, or juries trying to come to a verdict. Deliberation can be super useful because it allows individuals to share relevant evidence and information, which could help individuals' competence for the task at hand. But deliberation is also hard to do, right? Deliberation puts a big cognitive burden on individuals to articulate and argue for their own stances and to accurately evaluate the arguments provided by others. But hopefully with language models, we might have a new tool for structuring and mediating deliberation to hopefully reduce that cognitive burden and make engaging in deliberation more attractive. One study that nicely demonstrates this is presented by Argyle and colleagues, where they integrate a language model assistant into pairs of individuals deliberating over a divisive political topic. So as shown in the diagram up here, the language model assistant would become available to an individual and make suggestions for how they might rephrase their arguments to facilitate mutual understanding without materially changing the content of the arguments. So for instance, the language model might rephrase the argument in a more polite way or in a way that helps the individual explicitly engage with their opponent's view. And what they find in this study is that the language model rephrasings increase conversation quality and democratic reciprocity, both measured with surveys completed by the participating deliberators themselves. So moving down the y-axis here, we see that with more language model rephrasings, participants perceive the deliberation to be higher quality and more reciprocal, with the effects being most strong for the participant who is on the receiving end of the rephrased arguments. So in other words, the language model served as a kind of deliberation support system. It wasn't there to persuade or change minds. Instead, it served only to raise the level of discourse and mutual respect. And that seems like a good thing for collective intelligence because it could increase individuals' deliberative competence, and also because it could make engaging deliberation more attractive to a wider diversity of potential participants. Now, of course, language models aren't all good news for collective intelligence. And in our paper, we identify 4 ways language models could harm collective intelligence. One of these concerns is that language models might reduce functional diversity among individuals. The worry is that even if augmenting individuals with language models increases individual competence on average, it might come at too much of a cost in terms of reduced diversity at the collective level. So for instance, say we have a team of individuals tasked with developing a new product or making a forecast. If each of those individuals first turns to, say, ChatGPT to bounce ideas off of, then each of those individuals might be steered in a similar direction. And the team might develop correlated errors that compound rather than cancel out in the aggregate. This topic seems fairly well recognized, and there are several papers that touch on this issue already. One nice example is this study where they tasked users with writing argumentative essays under 3 conditions. Some users wrote their essay alone, some users wrote their essay with the help of the base GPT-3 model, and some users wrote their essay with the help of Instruct GPT, which is a model that's been tuned with human feedback, specifically to follow instructions. Then they analyzed the essays produced by looking at homogenization, or how similar the essays were within each condition, as well as the overall diversity of the essays in terms of the content and language used. And what they find is that the users who co-wrote with Instruct GPT tended to produce essays that were more homogeneous and less diverse than those who wrote essays alone. So for instance, here they evaluate the homogeneity of essays with a metric based on whether the same word sequences appear in different documents. And as shown in the plots up here, split out by different essay topics, the homogenization scores for the Instruct GPT condition, represented by the green boxes, tends to be higher than the other conditions. So to put it simply, users co-writing with Instruct GPT produced essays that tended to use the same phrases and raise the same key points. That seems like a potentially bad thing for collective intelligence, because if people increasingly turn to some shared language model for advice, we might see decreased functional diversity and more correlated failures. Now, after noting how language models might harm collective intelligence, a natural question to ask is, well, what can we do about it? How can we mitigate the harms without undermining the potential benefits? Well, the development of language models has been very fast-paced, and we certainly don't claim to have all the answers, but we do provide 3 recommendations. One thing we call for is what we say as truly open models, which means open access not only to model weights, but also to the code base and details on the training procedure and data sources. We're certainly not the first to call for this, but reiterating it seems important in the context of collective intelligence. The reason for this is pretty straightforward. A monolithic model landscape dominated by a handful of private developers increases the risk of potential harms, such as the reduction of functional diversity. And while having truly open models won't entirely prevent the centralization effects that accompany model development, it would enable a greater diversity of developers to build and fine-tune their own models. And that would hopefully steer us away from what John Kleinberg calls algorithmic monoculture. So to wrap up this short talk, I want to leave you with just a few takeaway messages. First, I hope you'll recognize that collective intelligence requires stewardship, and this seems especially important in the era of large language models. Second, appreciate how viewing language models through the lens of collective intelligence offers a mechanistic understanding of how their individual level use will emerge as collective level outcomes. What I mean by that is that desirable effects at the individual level won't necessarily be desirable at the collective level. So we need to consider how language models affect key elements of collective intelligence, like diversity, individual competence, and aggregation. And finally, recognize that to ensure the collective level effects of language models are desirable, whatever they may be, demands a proactive agenda for research and policy. And that's the agenda that my co-authors and I tried to outline in our paper. So go check it out if you want to learn more. Thanks for your time.
Thank you very much, Jason. To everybody and also the people who have joined, so was the first out of 3 talks. We'll have time for in-depth discussion at the end, but please feel free to ask questions in the chat or ask for a link for a paper as Mark already did. I'll collect questions for the end of the session, and the presenters are free to also engage in the comment section during the talks to answer maybe some of the questions. And with that, let's continue with Lucy's talk.
Hello, everyone. Screen sharing. Does it work now? Do you see the slides?
Yes, let's see them, or I see them.
Great. All right. Very glad to be here. I want to give you a short overview of our recent work along several papers that are connected through the idea of pluralistic alignment and thinking about aspects of it from the, well, computer scientist mindset, trying to train the LLMs right, model the LLMs right, and model everything that represents a human in some useful and safe way in those LLMs. And how this brings us to the concept of pluralistic LLMs and perspective taking. So our starting point has been understanding that in order to collaborate with humans, LLMs need to understand human context, right? And this human context can vary across social groups, across individuals, across cultures. In this audience, you all know this, that you might not get the same result for some generic queries dependent on where you which context you're in. So we expect, or we are used to seeing different biases in the LLMs these days, whether it comes to cultural variations, social biases, but also interpretations on the user side in terms of perceiving the outcome as toxic or perceiving the outcome as more or less empathic, or perceiving the model as having high or low social intelligence in the interactions. So in many ways, whether we look at it from a social bias perspective or social safety perspective or personalization perspective, we want the models to be kind of human-centered. We have very broad definitions of what this human-centered is, especially if you look at publications in the computer science realm these days. I think many people spend much less time on really working out this definition than many of our amazing fellows on the social science side do. So even if we don't have a fully worked out concept on what does it mean for the LLMs to be human-centered, we are all in agreement that we don't want them not to be human-centered. And the question is, if we want the model, if we agree that we want the models to be human-centered, to which humans are they human-centered now, and to which humans they actually should be human-centered, or how can we influence, or how can we even explain, how can we detect to which humans these models are human-centered in that sense, or human-aligned, you will hear sometimes. The hypothesis that we started from for a few years ago was looking into, are the current LLMs human-centered? Are the current LLMs US-centered? In terms of cultural bias. So our first paper was about looking into social stereotypes and perpetuating social biases in LLMs, and trying to figure out if this changes across cultures, if this is different in US and in Europe, and in, well, other parts of the world. And we saw that most of the papers that have been done so far are actually in evaluating LLMs just within the US realm, and B, evaluating more like BERT era models, looking into what's happening inside the embeddings, inside the learned representations. But there is much fewer experiments with actually comparing very large models because it's tedious to train them. But we took time to train them and took open source architecture, trained 6 large language models, so in the range of 3 billion parameters from the scratch, with exactly the same architecture, exactly the same data size, in English, German, French, Italian, Spanish, plus 1 multilingual model that had exactly 20% of the data of each of those 5, keeping everything else the same. And then we evaluated on general social bias benchmarks that people benchmark LLMs on these days. Also, these benchmarks are typically available in English, so we had to translate them to those 6 languages. That was validated by native speakers, but also validated for human evaluated for preserving the strength of the bias to make sure nothing gets lost in translation. Well, and what we saw was that when we trained the model on all languages at the same time, the model somehow gets rid of some of its social biases. So it performs much better in these social bias benchmarks in terms of having prejudices about, well, not having that many prejudices about who is more likely to perform certain actions. Like, is it more likely that my mom was cooking, or is it likely that my dad was cooking? Or should I say that I don't know, if this is not defined in the context? That's the type of questions that the models are evaluated on. And we see that all across the languages that we were able to test, the multilingually trained model gets less biased in terms of the benchmarks than monolingual models. But we were not really happy with stopping there, because the trying to figure out why was not very conclusive. We couldn't see a clear pattern between cultures. We couldn't see clear pattern between genders, between social demographics, between user groups. We wanted to see like what actually makes these multilingual models kind of less biased, and what even is the center of the social bias concept that we have there. So we've been wrapping our minds around how can we better explain what drives these like social and moral and cultural decisions in the LLMs, and how does LLM derives these representations from learning about different social groups, learning about different people that are in the training data and their subjective statements. So our understanding at that point has been, okay, we need to go beyond what has been done on social bias. We really need to look into representing humans, representing user groups, representing individual users, and looking at modeling the individual perspectives, and from there drawing conclusions back towards what's happening in social bias of the models, or what even is this social bias, which factors are there, and why do we call it bias and not just position, right? You might have seen these papers. I don't know if some of the authors are even in the audience. This is one of the papers arguing for LLMs wanting to show or are desirable to show reasonable pluralism, in the sense that we don't want to limit the output of LLMs just to say, okay, I can't answer. We don't want to fully personalize the output in the sense of, oh, I know that you're voting for Democrat, so here is an answer for Democrat. But we wanted to be able to exhibit some reasonable pluralism of opinionated answers instead of avoiding it. And we want to see to which extent we can force LLMs to do this, or convince LLMs to do this, to model this pluralism, and how well can we even evaluate it. So that's been our next line of papers, trying to model pluralism through personalization. We took a data set from Reddit, AITA. Some of you may know it. It's about, am I the let's say, bad person for performing certain social situation? And then people say, yes, you are, or no, you aren't, and provide certain judgment. So we could crawl this entire data set, plus all of the user history of everybody who ever commented in that data set, and learn user vector for each of those 100,000 authors that are in those social media data. And then we try to train a system to see, can we predict how a specific person with a specific background, given by what they ever said about themselves before, will judge this social situation? And can we even train a model that will convincingly provide the same arguments and talk the same way as these people do? So we tried many technical configurations, which are more or less complex in terms of modeling the users inside the model in the deeper layers, or just going for surface persona prompting with various length of the context, various granularity of the details about the persona. So the simplest setup you can imagine like this: you have on the left side some selected history from what the people said, what the given user said in the past. Then you have the instruction, given the self-disclosure sentences, try to generate a perspective for the given situation that is aligned with this person. And then, well, the model that we trained or that we fine-tuned generates the judgment of a provided situation. So a model which is good at that should be, well, able to step into others' shoes well, doing a good perspective taking, provide a good personalization from a different perspective. It's been difficult to evaluate this. We could evaluate if the judgment is along the same line, right? Yeah, you're a bad person, you're not a bad person. But evaluating if the person sticks to the similar argument or similar style was not working very well when we ask other people to compare it to the gold standard. So we did pairwise ranking with the assumption Well, if the model does well in this perspective taking, then more people will say that the answer is closer to the real answer of that person than to the answer of a different person, provided the other answers, the real answers of two people and their persona descriptions. Turns out when humans do it about humans, then they get it right in about 70% of the same data set. For the model, we got up to something like 65% accuracy, so actually pretty good approximation of an opinion of a certain person. In some cases, well, 40% of the cases, people actually even claim the model-generated response to sound more like the given person than the actual gold standard one. That was interesting. So yeah, let's say we have a technology with which we can, to a decent extent, model or forecast how individual person will talk about certain social situation. Now, what can we...
Sorry, Lucy, just for context, it would be great if you could finish up in 1 or 2 minutes.
Yes, sorry.
Thanks.
Yeah, this is more or less the wrap up. What can we do now when we can model individual perspectives, right? Like we can pretty convincingly forecast what one certain person will do. So let's have a personalized model which will say what I try to do. But not in all cases we want the model to really stop at that and like personalize to whatever I might desire and end the decision there. In many cases, you want to kind of continue with this overall alignment where you want to introduce some social boundary or like some fixed boundaries, moral judgments, common sense, social conventions, all of the things that shouldn't change with personalization. And then you try to find a balance between the two. And that's the last paper, which we will present next week at iClear, which is about trying to align from these individual personalizations to like overall consensus through dynamic human values with policy learning, and finding the right compromise on what the overall judgment of the LLM should be. Yeah, so from everything that we learned in these 4 papers, I basically just have 4 quick recommendations for the practitioners using LLMs for any subjective tasks. One would be, let's evaluate LLMs for how large spread of opinions they can represent. Right now we have benchmarks only with one solution correct. We want to have benchmarks where we reward models that can represent broader spectrum of opinions. This is hopelessly missing in our current computer science community. Proposition 2, let's model personalization and social bias jointly, so that we know what's really going on under the hood on the micro level, and then generalize from there. Proposition 3, when we do this, we can release the models together with their value cards rather than social bias accuracy judgments. So we don't have an objective 0.0 of social bias without introducing more other bias. So let's just drop the term bias and talk about a value card of where the model is positioned in terms of their core beliefs, values, and opinions, and do this with the model releases. And proposition 4, when we are evaluating behavior of the models, let's use agentic scenarios. Let's use, well, role-playing with social models and real behavioristic interactions rather than querying model personality, because what we see in all those experiments is that the models say that they preserve certain values consistent with a certain persona, but in most cases, they are not capable to behave according to that consistently, and that needs to be separately validated. So, thank you. Happy to discuss all of this at the end.
Yeah, thank you very much, Lucy. Let's just immediately move to Nicolas' talk, and then there's some time for discussion at the end.
Hi, everybody. Thank you very much for having me on the panel. And I will give a quite narrow talk on a research study that we did in the HACCP project on how we can leverage hybrid collective intelligence in medical diagnostics. And so very quick word on the HACCP project. Stefan already introduced it. So the objective of HACCP is to develop decision support systems that harness both the collective intelligence of human experts, but also structured domain knowledge and AI systems. And we have two use cases, medical diagnostics and urban adaptation to climate change. And I will be focusing on medical diagnostics here. And I want to start with the problem that we are trying to tackle. So in the US alone, nearly 800,000 people die each year or become permanently disabled because of misdiagnosed dangerous diseases. And so this really is one of the most pressing issues in medicine. So there's several promising research avenues to make the situation better. And so one is collective intelligence, and there have been numerous studies that demonstrate that pooling the judgments or diagnosis of several physicians outperforms the average individual physician. However, the problem with collective intelligence approaches is that they are rarely implemented because they are very costly, both in terms of time of skilled workers, but also of the associated organizational cost. And so, of course, another very promising research avenue is AI. And the applications that actually really made it into clinical applications are in medical imaging, for example, in cancer detection, but recently also large language models have gained a lot of attention. And so there have been numerous studies on large language models and how they can diagnose patients. And in the systematic review that recently got published by Takita and others, they found that LLMs already often match the ability of physicians. However, specialists still significantly outperform LLMs. However, LLMs seem very promising, but they also come with a few problems. For example, they hallucinate, they have biases, and sometimes they even lack common sense. And so in this study, we try to combine these two approaches and particularly use methods developed in the collective intelligence of humans and apply these methods both to LLM ensembles, but also to hybrid ensembles made up of humans and LLMs. And our research partner in this project is the Human Diagnosis Project, which is an organization that has developed a medical crowdsourcing platform that comes with a mobile application. And this mobile application is targeted at medical professionals. So users can sign up on the platform, create profiles, and give information about their seniority and their specialty. And then they can solve medical cases in the app. And here you see the user interface, and typically case information is displayed, and then users give a differential diagnosis. So we had access to a large number of medical cases through the Human Diagnosis Project. And these cases are made up of medical case vignettes that include patient data and, for example, the medical history of a patient, information about the symptoms and lab results. And typically in the application, they are passed to the user interface, and then users diagnose the cases. And so we had more than 40,000 differential diagnoses. Oops, sorry. Oops, sorry, I just minimized. Sorry, something went wrong there with the slides. So we had access to more than 40,000 differential diagnoses by physicians and an additional 10,000 diagnoses by medical students. And what we did then was to take the same information and pass it to large language models and ask the large language models to diagnose the same patients as the physicians did. And so for the prompting, we used a simple but systematic approach. So we had a base prompt that basically just instructed LLMs to diagnose the patient and passing also the case vignette. But then we also had additional small snippets informed by literature on prompting, like, for example, impersonation, telling the LLM that they are a medical expert, or also a few short examples included in the prompt that had example case vignettes and the example solutions. And so then for each LLM on a training set, we basically constructed different prompt combinations, and then for each LLM used the prompt that yielded the best performance for that particular LLM. So here you see an example on the left-hand side, again, the user interface. And then in this case, the correct diagnosis was peptic ulcer. And you see 2 differential diagnoses by LLMs and 2 differential diagnoses by humans. And in this case, all of them actually nominated the correct diagnosis, but you also see that the raw strings are all different because we had a free text elicitation. And so the first step to actually be able to compare these differential diagnoses is to standardize them. And to do this, we used this NOMAD clinical terminology, which is a very large medical knowledge base that comes with more than 300,000 entries. And all of these entries then have a unique ID, but they also come with a list of synonyms. And so we then used a natural language pipeline to match the raw string diagnoses to unique SNOMED IDs. And this then allowed us to actually compare the differential diagnoses and then also aggregate them. And so for the aggregation into a collective diagnosis, we applied weights on the solver level. Again, these were informed by performance on a training set, and we had different weights for each LLMs and an average weight for human solvers. And then we also applied a rank penalty depending on the position of the nominated diagnosis in the differential. And this then allowed us for each nominated diagnosis to calculate a score, which then created a ranking constituting the collective diagnosis. So I now come to some results. So on the x-axis here, you see the number of physicians, and on the y-axis, you see the cross-validated performance in terms of top 5 diagnostic accuracy. And so we see that the individual LLMs perform differently, but interestingly, forming an LLM ensemble of these different LLMs increased performance. And then on the right-hand side here, you see results for physicians. So this is the typical wisdom of the crowd effect, that the more physicians you select into the group, the better the performance gets. But now, interestingly, if we combine LLMs and physicians, we were able to even boost the performance more. And we see that the best results were achieved by hybrid ensembles made up of physicians and LLMs. And these outperformed both individual LLMs, but also individual humans and smaller groups of humans. And so these results were quite robust. So here you see the same analysis, but for different medical specialties that were in our data set, or the most frequent ones in our data set. And the analysis looks very much the same. For all of them, the hybrid ensembles outperformed individual LLMs and also individual humans and smaller groups of humans. And these results also held across different seniorities. So here we are looking at groups of medical students. Again, we see this typical wisdom of the crowd effect. But then if we also look at the results for combining LLMs with students, we again see that performance is increased. And interestingly, it can even be increased above the level of physicians. And so why does this work? We think this is due to the error complementarity of LLMs and humans. So what you see here is on the x-axis, the different LLMs, and on the y-axis, individual physicians. And these matrices correspond to the distribution of when LLMs and humans assigned the same or different ranks to the correct solution. And so if we look at this column where LLMs did not nominate the correct diagnosis, we see that humans actually nominated the correct diagnosis in a significant number of cases. And vice versa, if we look at this row where physicians did not nominate the correct diagnosis, we see that LLMs often mentioned the correct diagnosis. And so with this, I come to the conclusions. So at least in our study, we found that hybrid human AI collectives lead to superior performance compared to just LLMs or just humans. We traced this back to error complementarity, and the results were quite robust. So they held across different medical specialties and also across different expert seniority. And finally, we think that the method itself has potential to be applied beyond medical diagnostics. For example, in the other use case of the HACCP project, which is climate change adaptation, the important thing is that there is structured domain knowledge that allows to standardize and compare different responses. And if this is interesting to you, there's a preprint out. And of course, this work had a lot of different contributors. You can see them here. And I'm very happy if you contact me if you want any more information on this paper. Thank you very much.
Thank you, Nicholas. So now we have time for 10, 11 minutes of discussion. Please feel free also to write comments and questions in the chat, or raise your hand. I'll try to make a mix of topics that have been raised during the session, but also feel free to ask your questions live. See, there are also some questions coming in. Maybe if it's okay, I'll just kickstart one question with Jason. So you've said that the field is moving very, very fast, and actually it took us a bit of time to actually ensure that the paper is available to people. What has changed in the meantime? Kind of, what do you think? What would you have done differently, or what are new insights since the publication of this paper? What do you think is kind of on the horizon in terms of how to think about the problems you've mentioned?
Sure. Yeah. Well, I think one thing that we thought about but probably didn't get talked enough about in the paper is opportunities for collective intelligence between language models. So we mostly talked about how language models could augment, support, or harm human collective intelligence. But there's also the possibility that groups of language model agents could combine and produce their own kinds or new forms of collective intelligence. At the time we wrote the paper, I was only aware of maybe, I don't know, one or two examples of this. One of these done by a group with Josh Tenenbaum at MIT, where they looked at how allowing language models to talk to each other, so basically submit their own answers to questions on mathematical reasoning tasks, and then update their answers based on what the other language models had submitted, led to superior responses at the collective level across these language model agents. So I think considering that on a deeper level and sort of reflecting on how can we design language models that would work very well together to produce sort of machine-only collective intelligence would be an interesting direction to go.
Yeah, thank you. Maybe one follow-up question that comes from Joshua Becker. He's asking, given that the field is moving so fast, how much of what we learn today will still be true in 5 years? Or more importantly, how can we identify what is more permanent knowledge and what is more variable? And I think that's a question, I think that's very interesting to all of us. So maybe you, but also Lucy and Nicholas can give a couple of quick thoughts on this.
I can just comment. I think the question of how do we identify what is more permanent and what is more variable is sort of a $1 million question that I don't have an answer to at all. I think looking in 5 years' time, I think, at least in our paper, if we root ourselves more to sort of first principles of collective intelligence rather than current capabilities of language models, I think we're future-proofing our perspective a little bit. And so hopefully in 5 years, we'll still be good.
Lucy or Nicholas, what do you think about this?
Looking 5 years back, I think we would have hardly predicted that LLMs are where they are now. On the other hand, looking at 5 years back in human behavior, there is not that much that changed, right? So I think from that front, we can also a little bit extrapolate to the future of what are going to be human needs in terms of interaction and collaboration and support expected from the technology. As for the development of the technology and the boundaries and how accurately it can perform different tasks, I think we have to be ready to be flexible. Yeah.
And maybe one thing to add to this is, I think what will be changing is how people interact and judge large language models, right? Because at the moment, while the usage is gaining a lot of traction, there's still a lot of issues with trust and not knowing how well the large language models can perform for a certain task. And I think this will maybe become, with time, will just become a bit clearer and more normalized to different user groups.
Yeah, thank you. So also, if someone wants to ask a question live, please raise your hand so we can see it. Yeah, it's many interesting questions. So next time I need to crowdsource that. Let me check. Maybe maybe there are a couple of questions on Nicholas on specialties and both in terms of how the difference between human performance and LLMs depend on specialty, but also the potential of impersonation. So what do you think are kind of, I mean, in this project, we already went a bit in this direction, but what do you think is the potential of looking more into specialties or having LLMs impersonate specialties in medicine, but maybe also more generally when it comes to problem-solving skills?
Yes, so maybe with the impersonation. So we for this study we just really tested, for example, prompt variations with you are you're a medical expert, not really digging into the specialties, but the impersonation really didn't do so much, at least in our study. So the most or the strongest differences were really when including few shot examples or not. yeah, that I can say about prompting, but of course there's so we used a fairly simple approach for prompting, but there's really elaborate prompting techniques being developed, and I think there's quite a lot of room for improvement also by really kind of designing the prompts for the task that you're looking at.
Yeah, thank you. I see now, actually, Jason just answered one of the questions, but maybe just briefly on how task specific do you think is the contribution of LLMs? And I think there was also a related question about to what no, sorry, that was for someone else. Like, can maybe just briefly or just elaborate on what you've just answered to Bruno?
Sure. Yeah. So maybe to paraphrase, right? Is ChatGPT the right language model to enhance collective intelligence on problem-solving tasks, decision-making tasks, inference tasks, etc.? While it might help on average, I think the optimal language model would vary from task to task, and that's because, well, the right amount of diversity, individual competence, and the appropriate aggregation mechanism should vary from task to task and vary depending on the task environment, right? And so therefore, even if one language model seems good for many tasks, probably the optimal language model is different across tasks.
Thank you. I hope it's okay if I also ask a question to Lucy, which relates to something Jason discussed in his introductory talk. So Lucy, you presented this very interesting results on the multi-language model being, you said we shouldn't focus on bias anymore, but kind of a more neutral value alignment, which kind of suggests that it might be useful for certain tasks to rely on such models, as opposed to maybe models from different languages. On the other hand, that would probably reduce diversity. So I'm just trying to wonder what your thoughts are on what these insights on mono-language or multi-language models and the benefits that you demonstrated, and how that maybe trades off against functional diversity in the way that Jason discussed and in our paper.
Yeah, so from what we saw from our limited sample of the European space, our hypothesis is that the multilingual model kind of models a more diverse training at the kind of highest level proxy of like aggregating 6 nations. So in principle, you have a more varied representation of values than in the English models. Like what we see in the like US released models is that even when they are released as multilingual, in practice, still like 80%, 90% of the training data has been US English data. So the models are capable to speak different languages, but not necessarily different cultures. So the fact that we really like proportionalize the different languages actually made a difference on how well it was able to interpret different cultural perspectives. So I would hope we see more of this. I would hope it will be useful, and I would mainly hope that it will be in the future much more transparent on what we are getting for the models that we are using.
Yeah, thank you very much. So there were several questions. So is there anyone who wants to ask a question live? Because if not, it's now 6 p.m. Central European time, and so thank you very much for. Oh, actually, yeah, Bruno, let's do one question.
Oh, so the other day I was reading about, I think it was Meta that proposed the large concept models where they have this sentence embedding. So instead of having the model generate one token at a time, they generate whole sentence. And they were saying that using this sentence embedding, they were able to, I mean, the model was generating an embedding of a sentence, and this could be translated in many languages. Would that remove the need for multimodal dataset? Because the model is trained with embedding of whole sentences, so there's not really a language because you train on embeddings of sentences.
Thank you. Yeah. I don't know, maybe Lucy or.
Yeah, that's an interesting question. I mean, to some extent, the current models already do that, and it doesn't really help that much. I mean, my assumption why it doesn't help is that I think lots of these models translate the sentences from English to other languages, and even if the translation is human or native speaker, it's still like grounded in whatever the sentence was supposed to mean in English. So you will not introduce any culture specific or like locale specific comments that you wouldn't have in the original data, right?
Yeah, but so the reduction in biases comes really from the cultural things, right? So if I was to take the multilingual, translate everything to English, I wouldn't get biases too, right? I guess.
I think the reduction comes more from the content than from the linguistic form, than from the
Okay.
language form.
Yeah.
Yeah. So you would have like different concepts people talk about in the different languages.
Okay. Thank you.
Thank you. Yeah, and again, thank you everybody for joining. I'll just put a link in the chat. If you're interested in climate change and decision support system, please consider also checking out this webinar, which is actually happening, I believe next Tuesday already with our partners of Med Office. And there will be more webinars coming up. So yeah, please like and subscribe, as they say. You will find different ways to follow our content on the website. And thank you very much for hanging out, and have a wonderful evening. Bye.